For nearly half a century, two small spacecraft have been traveling farther from Earth than any other human-made machines in history. Their mission began as a bold attempt to explore the giant planets of our solar system, but it evolved into one of the greatest scientific journeys ever undertaken. In 1977, NASA launched Voyager 1 and Voyager 2 just weeks apart. At the time, few people imagined they would still be operating decades later. Their original objective was to study Jupiter and Saturn, taking advantage of a rare alignment of the outer planets that occurs only once every 176 years. This unique opportunity allowed the spacecraft to visit multiple worlds using the gravity of each planet to accelerate toward the next destination, saving enormous amounts of fuel while extending the mission far beyond its original plan. When Voyager 1 arrived at Jupiter, it transformed our understanding of the largest planet in the solar system. It captured detailed images of swirling storms, powerful lightning, and intense radiation belts unlike anything previously observed. One of the mission's most astonishing discoveries came from Jupiter's moon Io. Scientists expected a frozen, inactive world, but instead they found towering volcanic eruptions blasting molten material hundreds of kilometers into space. It was the first evidence of active volcanism beyond Earth, proving that distant moons could be dynamic worlds. After completing its study of Jupiter, Voyager continued toward Saturn. There it photographed the planet's magnificent rings in extraordinary detail, revealing countless narrow ringlets and hidden structures shaped by the gravity of tiny moons. The spacecraft also investigated Titan, Saturn's largest moon. Wrapped in a thick orange atmosphere, Titan hid its surface beneath dense clouds, suggesting an environment unlike any other known world. While Voyager 1 continued toward the outer reaches of the solar system, Voyager 2 followed an even longer path. It became the only spacecraft ever to visit Uranus and Neptune, providing humanity with its first close-up look at these distant ice giants. At Uranus, Voyager discovered an unusual magnetic field tilted dramatically away from the planet's rotation. Scientists also found new moons and faint rings, revealing that this distant world was far more complex than expected. Years later, Voyager 2 reached Neptune, where it observed the fastest winds ever measured in the solar system. It also studied Triton, a frozen moon where nitrogen geysers erupted from the icy surface, demonstrating that geological activity could exist even in the coldest regions of our planetary neighborhood. These remarkable discoveries completely changed the way scientists viewed the outer solar system. Instead of lifeless, frozen worlds, Voyager revealed planets and moons filled with motion, energy, and unexpected geological processes. But perhaps the spacecraft's greatest adventure was only beginning. After leaving the planets behind, both Voyagers continued traveling toward the invisible boundary surrounding our solar system. This enormous region, known as the heliosphere, is created by the constant flow of charged particles streaming outward from the Sun. It forms a protective bubble that shields our planetary system from much of the radiation found between the stars. For decades, astronomers could only estimate what this boundary might look like. Then Voyager reached it. In 2012, Voyager 1 became the first spacecraft to cross into interstellar space. Voyager 2 followed several years later, confirming many of the surprising observations made by its twin. Instead of encountering a sharp edge, the spacecraft found a complex transition where solar particles, magnetic fields, and interstellar material interact in ways scientists are still working to understand. For the first time in history, humanity was receiving direct measurements from the space between the stars. Every faint transmission arriving from billions of kilometers away carried information from a region no human-made object had ever explored before. And that was only the beginning of Voyager's most extraordinary chapter. Crossing into interstellar space was not the end of Voyager's mission. In many ways, it marked the beginning of its most valuable scientific chapter. Beyond the protective bubble of the heliosphere, Voyager entered an environment that no spacecraft had ever explored directly. Scientists expected this region to be quiet and nearly empty, but the data revealed a surprisingly active frontier shaped by invisible forces. One of Voyager's first discoveries was a dramatic increase in high-energy cosmic rays arriving from deep within the Milky Way. These particles, created by powerful events such as exploding stars, become much more abundant outside the Sun's protective influence. Their measurements confirmed that the heliosphere acts like a giant shield, reducing some of the radiation that reaches our solar system. At the same time, Voyager's instruments recorded plasma waves moving through the thin gas between the stars. Although space is almost a perfect vacuum, it still contains scattered atoms and electrically charged particles. These tiny particles can carry waves across enormous distances, allowing scientists to study regions that were previously beyond direct observation. Another surprise came from the magnetic field surrounding our solar system. Researchers expected a sharp change in magnetic direction after Voyager crossed into interstellar space. Instead, the field remained more organized than many models predicted. This unexpected result suggested that the boundary between the Sun's influence and the wider galaxy is far more complex than anyone had imagined. Every transmission from Voyager continues to improve computer models describing how stars interact with the surrounding interstellar medium. These discoveries help scientists understand not only our own solar system, but also the protective bubbles surrounding distant stars across the galaxy. Keeping Voyager operational, however, has become an extraordinary engineering achievement. The spacecraft relies on a radioisotope power system that slowly produces less electricity each year. To extend the mission, engineers carefully shut down non-essential instruments while keeping the most important scientific equipment running. Communication itself is an incredible challenge. Radio signals travel at the speed of light, yet they still require more than 20 hours to reach Voyager. Another 20 hours pass before a response returns to Earth. Every instruction must be carefully planned because there is no possibility of immediate control. Despite these difficulties, engineers have continued solving unexpected technical problems from billions of kilometers away. Software has been updated, faulty memory sections have been bypassed, and aging systems have been kept alive through creative engineering rather than physical repairs. This success demonstrates something remarkable. Voyager carries only a tiny fraction of the computing power found in today's smartphones, yet it continues operating reliably after nearly 5 decades in one of the harshest environments imaginable. Its survival is not the result of luck. It reflects exceptional engineering, careful planning, and the dedication of generations of scientists and mission controllers. Perhaps Voyager's most enduring symbol is the golden record attached to its side. Inside this golden disc are greetings spoken in many languages, music from different cultures, sounds of nature, and images representing life on Earth. It was created as a message from humanity, a small record of who we are and what we value. Whether another civilization will ever encounter it is unknown. The chances are extremely small, but the record represents something far greater than the possibility of contact. It reflects humanity's desire to explore, to learn, and to leave behind a peaceful message for the universe. Long after its scientific instruments fall silent, Voyager will continue its endless journey around the Milky Way. For millions of years, it will drift through interstellar space, carrying a tiny piece of Earth's history toward distant stars. Its mission reminds us that exploration is not measured only by distance. It is measured by curiosity, perseverance, and the willingness to seek answers where none have existed before. Voyager has not discovered alien civilizations or mysterious artificial structures beyond our solar system. Instead, it has revealed something equally extraordinary, a universe filled with natural wonders, hidden processes, and scientific mysteries waiting to be understood. As its faint signals continue arriving across billions of kilometers, Voyager remains a symbol of humanity's greatest strength, the courage to keep exploring, even when the destination lies far beyond the horizon of the known universe.